Okay, so hello everyone. Hope everybody is safe and healthy. So in this short span of sessions, we'll talk about certain topics which are included in the CCNA exam. Here we'll first start with the chapter 1, which is Introduction to TCP IP Networking. Here we need to know about certain abbreviations which include the OSI, that is Open Systems Interconnection, and ISO, which is International Organization for Standardization. Here we need to also know about the TCP IP model, which basically has 5 layers. First starting with the physical, which is the layer 1, data link layer 2, network layer 3, transport layer 4, and all the other layers are in the application layer, which includes which range from 5 to 7. When we talk about data link, we usually use the term frames. When we talk about the network layer, we use the term packets. And when we talk about the transport layer, we use the term segments. Examples of protocol which are included in application layer include HTTP, which is the Hypertext Transfer Protocol, SMTP, which is Simple Mail Transfer Protocol, and POP3, which is Post Office Protocol 3. Examples of protocols which are included in transport layer include the TCP and the UDP, which is the Transmission Control Protocol, and UDP is the User Datagram Protocol. Examples of protocols which are included in network layer include the IP and the ICMP. So the IP stands for the Internet Protocol and the ICMP stands for Internet Control Message Protocol. When we talk about the data link and physical layers, we have certain methodologies which include Ethernet and 802.11 Wi-Fi. So we'll first start with the application layer. Application layer is the interface between the software and the network. Here we need to know certain abbreviations which include HTTP, which is Hypertext Transfer Protocol, URL, which include Uniform Resource Locator, and URI, which is Uniform Resource Identifier. Let's take an example here. We have a web server and we have a web browser. Web browser sends an HTTP request which has the HTTP header, and it uses GET. So it sends the home.html to the web server. Web server receives the request and sends the data along with the HTTP header which has the message OK. If the web browser needs more information, web server can send more data through the file, but here it won't include the header as it already included the header in the previous messages, which saves the space. So the next layer which we are going to talk about is the TCP/IP transport layer. The transport layer provides the service of error recovery, which is done with the help of sequence numbers. The transport layer provides services to the layer above it, which is the application layer. So it is very important to note that each layer provides services to the layer above it. Let's take the same example which includes the web server and the web browser. The web server sends the data or the web page with the HTTP message, which is OK, which we learned earlier in the application layer. But here what will happen is the TCP layer will encapsulate it along with the sequence number. So the first message will have the sequence number of 1. The second message will have sequence number of 2. And the third message will have sequence number of 3. But here in this example, the sequence number 2, which has more data about the web page, gets lost. But the transfer continues and the TCP sends the sequence number 3 with the rest of the web page. But what happens is the web browser needs the web page part which includes the sequence number 2. So for doing the error recovery, it will send the message to the web server like I need the sequence 2 message. Here we'll talk about two different types of interactions which happen in TCP/IP model. One is the same layer interaction which happens on different computers, and one is adjacent layer interaction which happens within the same computer. The same layer interactions may happen within the same layer, for example the TCP layers of the two different computers, and the adjacent layer interactions may happen within the same computer. So the next layer which we are going to learn is the TCP/IP network layer. For learning the network layer, we'll take the following example. A packet needs to be sent from the source to the destination. The source has the IP address of 1.1.1.1 and the destination has the IP address of 2.2.2.2. We'll mention the IP address in the dotted decimal notation. So the source sends the packet to the R1, which is the default router. The R1 checks every router. So the R1 will compare the destination address, which is 2.2.2.2, with the known IP routes or the known IP output routes which are in the routing table of R1. So while comparing, it finds out that the router 2 is the next most favorable router where it needs to send the packet. So the router 1 sends the packet to the router 2 and not the router 3. The router 2 sends the packet locally to the destination while comparing or while repeating the same process of comparing the destination address with the known output routes. So one more thing I would like to mention here is what it does. So it encapsulates the following encapsulated messages into the IP layer or the IP protocol. The IP protocol may consist of the destination and the source IP addresses. One more thing which I would like to repeat and which is the most important point here is that every router present in the diagram will compare the destination address with the known output routes in the destination IP table or the routing table. So the next layer here which we are talking about is the TCP/IP data link and the physical layers. To understand this, we'll take the following example. Here the source sends the IP packet with the IP address of 1.1.1.1. The IP packet gets encapsulated using the Ethernet header and the Ethernet trailer. The entire frame is known as the Ethernet frame. Now it will get transmitted. The physical transmission of the bits of the Ethernet frame is done using the electricity which flows over the Ethernet cabling. Here it will receive the signals over the cables and will get de-encapsulated at the destination and will get the IP packet. Now one more thing which we need to know is about how the entire data encapsulation process occurs. First you have the data which gets encapsulated using the application layer process into the HTTP and it has the OK message. Then next it gets encapsulated using the TCP layer and it has the sequence number for error correction. Now network layer comes into the picture. It gets encapsulated using the net IP protocol which has the source and destination. Again, the physical layer encodes a signal onto the medium to transmit the frame. This is the same thing which gets repeated. We have different layers. It gets encapsulated through the application layer which has the HTTP, then comes the TCP layer, then comes the network layer, and then finally comes the data link layer which has the Ethernet headers and the trailers. The message gets transmitted via the physical layer. So here we'll talk about the difference between the OSI and the TCP/IP model. The OSI model stands for the Open System Interconnection Model, whereas the TCP/IP model stands for the Transmission Control Protocol or the Internet Protocol model. Clear winner is the TCP/IP model as we consider its relevance in the current period. The OSI model uses the common conventions of the PDU, which is abbreviated as the Protocol Data Unit. A common example which we can take to understand this abbreviation, which includes L2PDU. L2PDU, which stands for the data link layer. The TCP/IP model uses the conventions of the segments, packets, and the frames. The packets are used for the network layer, the frames are used for the data link layer, and the segments are used for the transport layer. As we see in this diagram, we have 7 different layers in the OSI model and the 5 different layers in the TCP/IP model. In the OSI model, we have application, presentation, and session. Each layer has some different functions, whereas in the TCP/IP model, all the 3 layers are combined and the application layer provides or maintains the function of the presentation in the session layer. So that's it for this session. We'll meet in the next session, which will have the second chapter of the module. Thank you very much and have a good evening.